All right, this is May, June 2021, paper 22. Okay, let's try to solve this. So he's going to ask you a very basic question, whether which one is electric, which one is vector, and which one is a scalar quantity. So acceleration is a vector quantity. Resistance is a scalar quantity because it doesn't have a unit, right? Momentum is also a vector quantity because it has a direction. He says, what are the conditions required for equilibrium? You see, equilibrium will be justified by two methods, or by at least from two perspectives. First, the resultant torque on the system should be zero, which means, in simple terms, means that there should be no rotation on the system. Rotation should be zero, right? So for example, if we have an object like this, either it is rotating clockwise or anti-clockwise, it shouldn't rotate. This is the first condition. So you will see this in the examination as the resultant torque or the resultant moment should be zero, something like this. The second condition required for equilibrium is that the resultant force should be equal to zero, which means that the object either moving or either not moving. If it is moving, it should be moving at a constant speed, because constant speed means that the acceleration is equal to zero, right? And if it is not moving, that means the forward force or the backward force is exactly equal, producing no resultant, and hence object is not moving in any direction, right? Even in the case of constant speed, the forces will be equal, the forward and backward. So primarily what we're trying to say is that the resultant forces, or all the forces acting on the object, should be zero. There should be no acceleration. We have a question in which there is a floating object and so on. So I believe that this question is going to be about upthrust, or at least buoyancy. Let's see. The weight of the cylinder is given, the cross-sectional area is given, the height or the depth in which the solid is dipped, that is given, the density of water is given, and then there is a wire or a string attached, which of course may be providing a tension in the downward direction to counteract this block moving upwards. Let's see. Again, all the data is also given in this part as well. Let's move ahead. And this is important. He says that the system is in equilibrium, which means upward and downward forces will be equal. He says calculate to three significant figures the upthrust acting on the cylinder due to the water. You see, the formula for upthrust is very simple. It simply says rho g v, and v is the volume of the liquid that you have displaced while the object is actually partially sunk in the liquid, or however it is going to go. So let's see how we are going to calculate this. So we see that this part of the solid is actually inside the liquid. So only this amount of liquid would have been displaced from its own position. So to figure out its volume, we have this cross-section area and the height or the depth inside the liquid. So simply the density of the liquid that it is in is 1000. This is what it displaced. The gravity is 9.81, and the volume is found by two parts. First, multiplying the cross-sectional area, which is 0.0230, and multiply this with the height, which was 0.190, and then closing the bracket for the volume. So we find out that this is going to be 42.9 newtons, which comes out as 42.9. Generally in physics, we take up to two significant figures, but he said that it should be three significant figures, so we have no other choice. He says that the tension in the wire is 15 newtons. No problem that if the block has a weight of, let's say, the block has a weight of 28 newtons, and the upthrust acting on, because of the liquid on the object, is 42.9, which is roughly 43 newtons. The resultant, and if this is in equilibrium, then most definitely the wire or the string attached should be providing the rest of the force to keep this, or to hold this block in place. So we simply subtract these two numbers, or we can say that the tension in the spring plus the weight is actually being held down by the upthrust. So tension can be found easily by taking this over there, subtracting this number, and when you're done with this, you'll get your answer as 15 newtons. So we understand that the string will have a force of 15 newtons acting in it. He says you want to calculate, or you have to calculate the stress in the wire, and the cross-section area of the wire is given to you. Now, first, we need to convert this area into a meter square. So how to do that? Simply 3.2 divided by 1000 square. All right. This is a shortcut that I have. Anyways, you can go back to mathematics in the ratio method, and you will see that you will come down to this. So anyways, to find out stress, we have force over cross-sectional area. The force in the string is 15 newtons, which was found in the previous part. The cross-sectional area is already given, but it has to be converted into meter square. So 1000 square. When you are done with this calculation, you'll find out that this is going to be 4.7 into 10 raised to power 6 pascals. So this is 4.7 into 10 raised to power 6 pascals. Moving on to the next question, it says that the surface of the water gradually rises until it is level with the top face of the cylinder. So water level is rising. It is at this point, then eventually it is at this point, right? So water is going to be at this level. All right. So what will happen? You see, if you use the upthrust formula again, rho GV, you realize that volume was actually equal to cross-section area multiplied by the depth or the height or the length of the cylinder. When you do that, your length of cylinder is now increasing. So if you increase the height that is inside the liquid now, the value of volume increases and it increases the upthrust. Now, if the upthrust increases, if you go back to the system's balance, which was this one, the upthrust previously was 43. Now it is increasing. If that is the case, then when you take 28 on the other side, because weight cannot change, right? It has a constant weight, it has a constant shape. When you keep on increasing the upthrust, even if you subtract 28 from it, your answer of tension is going to increase. The wire, the thread that is holding everything in place would have to make a larger effort to keep this in place so that it stays in equilibrium. So this is the basic theory of the question that he's going to discuss with you. It says state and explain qualitatively in variation of the strain energy stored in the wire. Now, as we have established that the tension is going to increase, and we know that the formula for strain energy is 1/2 Fx. If the strain, if the extension, if the force is increasing, then most definitely the strain energy overall will also increase. So how will you write down the answer? You will say that the upthrust is increasing. Why? Because upthrust is proportional to the volume or the change in volume. The change in volume increases, the upthrust increases, causing the the tension in the strain to increase, and the strain energy or the formula of the strain energy is half Fx. So force increases because of the tension, so the strain energy increases. So this is what you will find in the marking scheme as well. So we have this system, right? He says that it already has an initial speed. It is moving from a height of 1.5 meter, displacement for 1.5 meters. It is going to have a speed of 8.7 before it hits the ground. He says calculate the speed u. Very simple equation, v square equals to u square plus 2as. Right, since everything is moving in the same direction, the value of g, even if you take it as negative, would not matter because speed downward is negative and this speed is also negative. So every negative balances out, right? So don't need to worry about this one. So we have the final speed is 8.7 square, u square we don't know, 2 into 9.81 into the height above the surface was 1.5 meters, which is this one. So we get u after algebra, we get u as 6.8 meters per second. Simple as that. It says state how Newton's third law applies to the collision between the ball and the ground. You see, this is what he's talking about, that when the ball eventually collides with the surface, what's going to happen? So the ball applies a force on the ground and the ground applies a force back on the ball, and they're going to be equal and opposite. So we simply say that during collision, right, during collision, the ball exerts a force on the ground. Why? Due to a change in momentum with respect to time, and we know that this is what force is. So when it does that, the ground also applies a force on the ball which will be equal yet opposite to the force applied by the ball. Okay, fine. So part C, the ball is in contact with the ground for this much amount of seconds. The ball rebounds vertically with a speed of 5.4. The mass of the ball is this. The magnitude of change in momentum, no problem over here. We see that the ball actually comes in with a speed of 8.7 and tries to go back with a speed of 5.4. So it's a matter of perspective. If you take downwards direction as negative and upwards direction as positive, and you're trying to find out the change in momentum, then by formula, change in momentum should look like final momentum minus initial momentum. So mass is 0.059. So 0.059, the final momentum is it's going upwards. That will be 5.4 positive minus mass 0.059 into velocity, initial velocity. It was moving downwards with a speed of 8.7. So if it was moving downwards, I should add a negative sign because momentum is a vector quantity. So if you notice closely, because of this negative of the formula and this negative of the direction, this is going to get added together because negative multiplied by negative makes it positive. So what are you left with? After you solving this whole equation, you're left with 0.83 Newton seconds. So 0.83. You could have done this alternatively in a much easier way. If you have taken the mass common on the outside, this would have been 0.059. And straight away, if you realize this because of extensive practice of these questions, you would have realized that the velocities will be added together because of the double negative sign. So you could have simply added 5.4 plus 8.7. This will also give you the same answer. This is just a mathematical technique. This is not a physics technique, right? Okay. Question number second part. Determine the magnitude average resultant force. No problem in this part as well because we know that standard formula for force is rate of change of momentum. And we understand that that is 0.83 from previous part. And the time taken for this collision to take place is given in the question as 0.091. So 0.091. The force experienced during the collision is 9.1 newtons. So 9.1. It says user answer is to C2, which we have just calculated, this one, to calculate the magnitude average force exerted by the ground on the ball. Now this is a bit tricky. You see, when the ball actually comes in contact with the ball, with this ground, it will most definitely exert a force of 9.1 newtons because only then the ground can exert a force of 9.1 newtons and the ball will start moving upwards with a velocity of 5.4, I guess, in the previous part. Yes, 5.4 meters per second because of this, right? But there is a problem. The problem is that we're just thinking about the momentum of the ball. What about the weight of the ball? Is it not in the downwards direction? Is it not acting downwards? So not only that there is a change of the force is being projected, being produced because of the change in momentum, the ball also has some weight, right? So the ground not only observes that it has to exert a change in momentum force, the ground also has to apply a counteracting force compensating for the weight of the ball. So what is the ground experiencing? The ground is experiencing two forces at the same time. One due to the change in momentum and the other due to its weight. So the total force exerted by the ground would be equal to 9.1 plus mg, which will be found by multiplying the mass of the ball, which is 0.054, I guess, 4559, into 9.81. So the final force comes out as 9.7 newtons. 9.7 newtons. This is why you can experience this in daily life as well. What if, for example, you're standing and in your hand you have a small tennis ball? If you're just carrying it, you're going to feel its weight only. But what if somebody throws that ball towards your hand? Will you feel a force greater than the weight of the object or less than? As you were already holding it, so you already have a perspective. You will feel a force slightly greater than the weight. Why? Because not only that there is some weight of the object, there is also going to be a force due to the change in momentum. Because the object, after it has fallen down, has become stationary. So it has lost that momentum and converted that into force. Okay, part D. Without using values, of course, he says what will sketch the graph of time t. He says it hits the ground at time t equals to 0. If values were required, then what would the graph look like? You see, at the beginning of the journey, it would have been moving at a speed of 6.8 meters per second. And at the end of the journey, it was moving at a speed of 8.7. Now, I understand that the values are not required, but in the interest of past papers, I have seen these questions pop up in P2 as well. So that's why I'm including these values. Otherwise, they were not required. Your graph would have been simply like a straight line like this. Why a straight line? Because I know that the gradient of speed time graph, represents acceleration. And since the whole system is falling under the influence of gravity, the value of gravitational acceleration is 9.81, which is constant, right? That's why it's going to be a straight line like this. He says that in practice, the A resistance not, yes, we know that, right? State and explain the variation, if any, with time t and the gradient of the graph in D when A resistance is not negligible. This is a case of terminal velocity. Now, of course, this is not going to achieve terminal velocity, but we understand that this topic overlaps with that. If that had been the case, then the graph would have gone something like this. The gradient would have decreased with the passage of time. Why? Because weight, which is mg, minus drag according to F equals to ma, the drag would have increased with speed, leaving behind less and less resultant, causing less and less acceleration. So the gradient would have reduced, right? So it would have become like this. And you've seen this in example in the terminal velocity case when the graph actually becomes flat. This is what I'm drawing this inspiration from, right? This is what I'm referring to, so that you can link this topic to that one. So how would you say, what are you going to see? State and explain, right? You will see a curve with reduced gradient. And why there is a reduced gradient? Because gradient represents acceleration, and acceleration is proportional to resultant force, and resultant force is proportional or at least dependent on drag, and drag is dependent on speed. So as you increase speed, drag increases, resultant force decreases, acceleration decreases, gradient decreases. That's why there will be a curve, right? So there is a complete chain of thought behind it. Question number 3 is from work, power, energy. A child of wave 330, okay, fine. Top of the slide, okay, fine, right? Data is given, okay, fine, right? This is important. He says that it has a kinetic energy of 540 joules. And has it started from rest? Yes, it has started from rest. So previously its kinetic energy was equal to 0, but it had some mgh or gravitational potential energy because it is standing above some height, right? Okay. These are initial predictions. Let's go ahead. It says find the difference in gravitational potential energy from x to y. So from x to y, we will realize that in reference to the Earth, the difference is only this much, right? Even if it comes down, gaining gravitational potential energy, it goes back up again, losing it again. So the actual investment or the actual addition of energy is only because of this change in height. Only this height is responsible for adding energy in terms of gravitational potential. So our formula will become mgh, and we know that mg is already, I think, given to you as 330 newtons. So this is already mg. So 330 into height difference, which will be 4 minus 1.1. When you're done with this question, you get your answer as 960 joules. So 960 joules is your answer. Now, please notice at this point, what have you invested in the system in terms of efficiency perspective, right? This will come in handy in the next parts. I've invested 960 joules. I got back 540 joules in terms of kinetic energy. And this is what we say, that any object falling from a distance, the gravitational potential energy converts into kinetic energy. But what have I invested? I invested 960. It only translated into 540 kinetic energy. Where has the rest of it gone? The rest of it has been converted into friction, or you can say it has been lost due to friction, which will be the next part. You see, it says the average resultant friction force is 50 nu, 52. By considering the energy changes, determine the distance moved by the child. No problem. We know that the work done is equal to force into distance. But what work done has been done against friction? You see, again, coming back to this problem, we invested $960 or 960 joules. We got back, or we can see with our own eyes, 540 joules of kinetic energy. Where is the rest of it gone? The rest of it has been wasted in heat due to friction. So we will take the subtraction of them. So the actual work done available will be 960 minus 540, because something is missing. This is not accounted for. Where did it go? It has converted into heat. So force is 52 newtons, as given by the examiner, right? So what is the distance, or how long should it would have moved against the influence of 52 newtons of force to produce such a change? So it has lost 420 joules because of friction. So the distance comes out as 420 divided by 52 gives you a distance of 8.1 meters. So this whole curved path length, starting from this point, going from this line up to this line, this whole length of path is actually 8.1 meters with all the curves and straight lines and everything else included, right? Okay, next part, he says that the object actually initiates in this direction. Okay, fine. Do we have a velocity? I don't think. Yes. He says calculate the speed at 0.5. No problem. He carries a kinetic energy of 400 and 540 joules. We know that this is half mv square. To find out the mass, we need to divide its weight with 9.81, and velocity square is what we will find. 540 is given to us. We find velocity to be 5.7 meters per second. So it will initiate at 5.7 meters per second at an angle of 41. And then we can, of course, make components later. Yes. He says the speed of the object at point Z. At point Z, we realize that this is the maximum surface, maximum height. So there will be only horizontal component. The vertical component would have become 0. So at that point, the cos component will actually take part in this. So this would only be the horizontal component. That is why it's the maximum height now, because it can't go any further up. The vertical component has become 0 at that point. This is what we've learned in projectile motion, and to understand it better, you can go watch the video of projectile motion uploaded on my channel, right? So we have 5.7, but a cos function, cos of 41. This comes out as 4.3 meters per second. So this is 4.3, and this is 5.7. Moving on to question number 4, question from waves. Progressive wave is has a period. So of course this is the time for one oscillation. And what is an oscillation? It could be a particles moving up and moving down and then back again, moving through crest and trough and then coming back. For a longitudinal wave, it would have been a motion from crest to crest, right? So it's primarily based on the motion, because it's a progressive wave, the particles are moving, but it's transferring energy. Stationary waves don't transfer energy. So that is why there is a distinction between progressive waves oscillation or period and in a stationary wave. State the principle of superposition. No problem. We understand that there need to be two waves of what? Same nature. For example, sound with sound, water with water, right? They need to meet, or you can say they need to interfere in 3 dimensions somewhere in the medium, right? The resultant displacement will be formed. There will be a resultant displacement by simply sum of individual amplitudes or displacements at that particular instant. Simple as that. For example, if there is a wave that is actually moving like this, and there is a wave that is a slightly phase difference apart, no problem. If I want to find out the displacement at this point or at this point, we simply, what we do, we check the amplitude of A, displacement of A, we check the amplitude of the blue one and the red one, and we simply add them together based on their signs. If this is positive, that is also positive, the amplitude will be positive. No problem. So this is what superposition is. Electromagnetic wavelengths, okay, fine. Wavelength is given. This is important, going to play part in the next parts. Source X, okay, fine. This is also a source. This is also a source. And Z is the point of where the detector exists. So the detector may be moving in this direction, detecting whether there is a constructive interference or destructive interference, what's going to look like. So it says that the distance XY is given to us. Okay, fine. This is also given to us. Fine. State the name of the regional electromagnetic spectrum. This is again based on memory. You are supposed to memorize this, that where this wavelength belongs to. Okay. So that is going to be a microwave. It says calculate the period in picoseconds of wave. Now this assumes that you recognize that this is a microwave. So using V equals to F lambda, we understand that from gamma rays up to radio waves, everything or every electromagnetic spectrum has a constant velocity when they move through vacuum, at least. So that is going to be 3 into 10 raised to power 8. This is the information that he thinks you should already know. So we simply use F to find frequency first, 0.04. So frequency 7.5 into 10 raised to power 9. To find the time period, we simply divide 1 over F. Please keep in mind that prefixes are going to be a part of this. So into 10 raised to power 9. So time period comes out as 133 into 10 raised to power minus 12. But up to 2 significant figures, this is going to be 130. Now minus 12 is pico, right? He says, show that the path difference at point Z between this and this is 3.5 wavelength, where lambda is the wavelength of the waves. And this is a very easy and understanding part. You see, you could have done it in two ways, but I recommend the easier one. First, take the difference of both distances, right? The difference of both would become 1.380 minus 1.240. Then divide this with the wavelength, which is 0.04. That is how you calculate the path difference in terms of wavelength. You see, when you calculate this, you'll get your answer as 3.5 lambda. What does that mean? It means that if a wave had originated from these two sources, for example, let's say there is a wave that is coming towards Z like this, and there is another wave coming from Y that is going to come like this, for example. For the sake of example, let's say that if this has made, for example, 100 wavelengths to go from X to Z, it needed 100 wavelengths for the sake of example, then this would need 100 minus 3.5 less wavelengths because it is closer and this is further away. This is what the path difference tells you. It tells you the difference between them in terms of wavelength. And why do we need this? We need this to figure out whether this is a constructive interference or a destructive interference. If you get path differences as 0.5, 1.5, 2.5, 3.5, a factor of exact 0.5, that is destructive. If you get a whole number or any other number, for example, 1, 2, 3, 1.1, 1.2, or 2.3, 3.4, 3.33, 5.7, anything other than the 0.5 factor, that is a constructive interference. For complete destruction, we need the gap of half a wavelength. Okay, all right. So we've calculated this part on the screen. It says calculate the phase difference between point Z. You see, since this is 3.5 wavelengths away, the 0.5 wavelength is actually 180 degrees apart, right? And the rest of the three lambdas or three wavelengths are calculated as 360. So when you add them simply together, you will get 1260 degrees answer. So this is going to be 1260, or you could simply have said that there is a phase difference of 180. That is also acceptable because they are out of phase with each other. That's why there will be a destructive interference. It says state the intensity at Z. There will be no intensity. Why? Because there is a destructive interference. All right. Next part, he says that the frequency of X and Y both decrease to the same, some lower number. They stay within the same region electromagnetic. Okay, they still remain microwaves. Describe the effect of change in the pattern intensity, maxima, and minima along the path of the detector. You see, since these are actually two sources, I can consider them as analogous to a double slit experiment. So that formula is AX equals to lambda D, right? And since he's talking about decreasing the frequency, which is over here, so I don't have the frequency over here, but I know that V equals to F lambda. To include frequency in this part, I need to take F over there. So this becomes V over F equals to lambda. So in place of lambda, I can replace this. So what does this new equation become? It becomes AX equals to V, speed of light or speed of electromagnetic spectrum, multiplied by D divided by F. Now what he is asking us is what happens to the separation of maxima and minima. So that is the fringe separation X. Right, we know this. So what is the relationship between X and now frequency? So if you decrease frequency, as he has mentioned, the separation increases. So this is what you're going to write down over here, right? So since he's only asking about describe the effect, we're not getting into the reason. We simply write down that the separation increases. For example, if previously we were getting a constructive and destructive interference over here, this is constructive, let's say this is constructive, this is constructive. Now they're going to go further apart. So you will find the constructive or destructive interferences very, very far apart in comparison to before. Okay, so this question is define ohms. Now notice that ohm is actually a unit of resistance. It's not resistance, it's a unit. So to define any unit in physics, what you do, you find a familiar formula. You make R the subject of the formula and you realize this is going to become V over I. Now, please be advised, we are not defining resistance. We are defining the resistance's unit, which is ohms. Now, when you have to do that, you just keep everything in the formula as 1 and explain it in English. Simple as that. So what you can say that when 1 volt is applied across a resistor, and if it causes a current of 1 ampere, then the resistance of the resistor is 1 ohms. Simple, right? Similarly, if you had to define pressure, for example, if you had to define pascals, we know that Pascal is a unit of pressure. So pressure is equal to force over area. Then you will say that if a 1 Newton force is exerted or is experienced by or exerted on an area of 1 meter square, then the pressure on that area will be 1 Pascal. So when you define units, you put everything 1 in the formula and just talk about it. Now it says that the wire is made of resistivity rho, the length L, gradually, the length L of the wire is gradually increased. Okay, fine. Assume that the volume of V of the wire remains constant and its length is increased. Show that the resistance R of the extending wire is proportional to L square. So we know that the formula of resistance is rho equals to rho L over A. But first we need to explore the relationship between the volume, right? So we understand that the volume of any spherical conductor like this one or a piece of wire is actually a product of its cross-sectional area with the length L. So let's take volume as AL, right? If you make A the subject of the formula so that we can replace it over here, this becomes volume divided by length. Simple as that. Okay. All right. So let's replace this in the standard equation of R equals to rho L over A. So A was equal to V by L. So what does that become? Rho L divided by V by L. This becomes rho L square by V. Right? So from this, we can realize that resistance has come out proportional to L square. Okay. One more thing. He says that the length is increasing. If the length is increasing, the cross-sectional area would be decreasing, but all at the same time keeping the volume constant. So even here, the volume was constant. That's why we can draw this proportionality. The type of material is same, the volume is same. That's why we can say that the resistance is now proportional to L square, because rho and the volume are actually constants. Okay. All right. So this is a question about internal resistance, battery, voltmeter, so on and so forth. Let's see what's happening. So it says that the resistance R is varied because that's a variable resistor. We can see that over here. This is a variable resistor. We can vary its resistance, right? So I and V are plotted. Okay, fine. Where is the voltmeter connected? The voltmeter is connected across the resistor only. Okay. And we can see that this is actually the terminal potential difference. This is actually the terminal potential difference. What is left on the outside of the battery? Okay, granted. He says use the graph to find out the EMF. You see, when the current is no more, when there is no current, that is the EMF. Why? Because as the current starts passing through, it will lose some voltage across the internal resistance. When there is no current, it will provide the maximum voltage available, or it will provide, or it will show the maximum voltage available. So based on this idea, we can see that counting the number of boxes, we can come down to this conclusion that this is going to be 2.4. You can pause the video at the graph location and exactly find out the voltage at this point. Or if you have the exam paper with you in a printed format, you can count the boxes and get to 2.4. It says use figure 5.2 to determine the power dissipated in the variable resistor when there is a current of 5 amperes. Okay, fine. So whenever there is a current of 5 amperes, according to this diagram, the current can be located from the graph, and the current comes out as 1.3 amperes. At a current, voltage comes out at 1.3 volts at a current of 5 amperes. So we have a formula for power, which is P equals to IV. Current is 5 amperes. Voltage was 1.3 volts. This comes out as 6.5 watts. So this is 6.5 watts. Okay, fine. Let's move to the next part. State what is represented. Now this is an interesting part. What is represented by the gradient of the graph? Any common person, any common student would realize this, that the gradient is simply y-axis, because change in y divided by change in x. So the unit on y-axis is voltage divided by unit on x-axis is current. When you divide this, this is actually resistance. So any standard normal student or an average student will write down that this is actually resistance. But when you look at the marking scheme, he says this is internal resistance. How is this internal resistance? You see, if you make the equation for this circuit, this system, this equation is actually the EMF is equal to the voltage lost in internal resistance plus the voltage lost to the external resistor. our voltmeter is actually connected to the external resistor. And this is what the graph represents. So our external resistor voltage is being measured and plotted against time or plotted against current, right? So we need to make this the subject of the formula, right? So if this is supposed to be the formula, then let's take this over there. So what does that become? Voltage on the external side is equal to the EMF minus voltage lost in the internal resistance. Let's make this IR, because we know that voltage is equal to IR. And of course, EMF lost to the internal voltage is what is left on the outside, and that shows across any appliance connected on the outside of the cell. This is what terminal potential difference is. So this is what we have plotted, right? Now let's compare this with Y is equal to mx plus c. We realize that this is a bit in an odd orientation, but let's rearrange this equation. Because we can see that the gradient is negative, it means that this is actually linked with this. And since we know that y-intercept is actually EMF, because this is the idea that we used to calculate this, how do we find the y-intercept? We find y-intercept when x equals to 0. When you make x 0, then you will find the y-intercept according to mathematics, right? So we understand that when you make this x 0, whatever value you get is actually the y-intercept. So that is mathematics linked with physics, at least. Okay, let's rewrite this equation. So I'm writing this as V equals to minus IR plus E to compare this easily with Y is equal to mx plus C. So I have drawn the external voltage on the y-axis and the current on the x-axis. Let's isolate everything. So Y is equal to mx plus C. I realize this that the y-intercept is the battery's EMF, so not concerned with that. Let's carry this further. I have said that this is negative IR and this has to be compared with mx. What have I drawn on the x-axis? Current is drawn on the x-axis. So let's re-isolate this. So negative R multiplied by current is what is mx, and so on. So on x-axis I have the current, and on the gradient I have the internal resistance and the negative of internal resistance. So a thoughtful student would have written down that this is actually the internal resistance, the negative of internal resistance. Negative was implied, or you can say it was, write it or don't write it, doesn't matter, but it was internal resistance, not resistance only. You would not have gotten the credit if you just had written down resistance, because that's common knowledge for everyone. Okay, so this is about alpha stating experiment. Okay, fine. He says state what is inferred, what can be deduced about the structure of the atom from this result, that angles greater than 90. We could have deduced that the nucleus is positively charged, right? The first conclusion. And the nucleus has all the mass, or is very massive, because scattered through angles greater than 90, that means that this was a gold foil. You introduced alpha particle, they came back. They were deflected like this. So they were unable to move something at the center of that atom. They were unable to move it from its position, which means that it must have been much, much more massive than alpha itself, which gave us the conclusion that nucleus is a massive quantity, or is a massive entity. An alpha particle is made of other particles, yes, we know that, and one of these is proton. State whether proton is a fundamental particle. No, previous belief was that proton is a fundamental particle, but now we know that we have even more fundamental particles than that, even smaller than protons. So this is not a fundamental. And why do we say that? What do we have to back it up? Because it is made out of quarks, which to this day, to this modern age, are the known fundamental particles. He says the radio source, if alpha beam, average current is this much. Okay, fine. Calculate the number of alpha particles passing in 1 minute. No problem. So we have current is equal to charge divided by time. Let's figure out the charge first, right? So in place of current, we have 6.9 into 10 raised to the power minus 9 equals to charge. How to calculate charge? The number of electrons, the charge on one electron, which is 10 raised to the power minus 19. And because alpha is 4,2, it has 2 protons. So there are 2 charges as it is moving through the circuit, or wherever it is moving, right? Divided by the time, which is 1 minute. So this will be divided by 60. This is what we are supposed to find out: the total number of electrons, the total number of charges, the total number of charged particles moving to create a current of this much in 1 minute. So when you find n, this is going to come out as a big number, which is going to be 1.3 into 10 raised to the power 12 atoms. So it is disintegrating 1.3 into 10 raised to the power 12 atoms in 1 minute, at least a radioactive decay. Okay. So the alpha particle in vacuum in C enters a uniform electric field. Okay, fine. We know that alpha particle is a positively charged particle. Let's assume positive plates and negative plates for our own self, and alpha particle exists at the center, no problem. Now he says that the magnitude acceleration due to the state, and explain what's going to happen to acceleration. It enters a uniform electric field where the velocity is in the same direction as the electric field. You see, the velocity could be in this direction. And is the electric field in the same direction? Let's make it out. So electric field is from positive to negative. So if this is electric field, this tells me that this plate is positive and this plate is negative, right? And if this is the case, then this positive charge is moving towards the negative plate, which means it is going to get accelerated, right? So it's acceleration, right? The acceleration is there, but acceleration is not increasing or decreasing, because although this is not a part of your course anymore, but force is equal to QE. The electric field is constant, the charge is constant, then the force is constant. So F equals to ma, the acceleration is also constant. Okay, but there is an acceleration because it is moving towards the negative plate. It says nucleus X is an isotope of nucleus Y. Okay, the mass of nucleus X is greater than nucleus of Y. Both nucleons have the same uniform electric field. State and explain whether the magnitude of electric force acting on nucleus X and nucleus Y is greater or same. You see, the electric force is being exerted because of the charge, and if they are isotopes, then the number of protons in X and the number of protons in Y are equal. If they have the same charge, they experience the same electric field, the force, at least the force, electric force, is constant. It will be same, although they will experience different accelerations, because when we put F is equal to ma, since they have different masses, their accelerations will be different, but the amount of force experienced by both of them will be same. You see, I have a box, let's say it experiences a resultant force of 100 newtons, but it has a mass of 2 kg. Okay, fine. I have another box that is experiencing a resultant force of 100 newtons. Okay, fine, but it has a mass of 20 kg. Of course the resultant force is same, but they will experience different accelerations according to F equals to ma. But since he only asked me about electric force, I will say that the electric force will be same